Greetings. So we are here today to discuss physics, the application of Newton's law. First and foremost, what is physics? Physics is the study of energy and matter in space and time and how they are related to each other. For example, velocity and acceleration are used by physics to show how things move. Newton's law of motion. Newton's law of motion was discovered by Sir Isaac Newton. From his discoveries, he discovered the three laws of motion. The first law of motion, it simply defines as if a motion is at rest, it will stay at rest unless it is acted upon by a force. Second law, it shows the idea of objects that are dependent with two variables, which is net force and mass of the object. In simple terms, if a force was applied to an object at rest, it causes to accelerate in the direction of the force. Third law states in every action there is a complete equal reaction. For example, when you jump, your legs apply a force to the ground, and the ground applies an equal and opposite reaction force that propels you into the air. So that concludes the three laws of Newton's law of motion.
Now I'm here to discuss its application on simple machines. But before that, what exactly are simple machines? Machine came from the Greek word mechein, meaning to help make things easier. A simple machine is by definition any device that changes the force direction or magnitude. Examples of simple machines are levers, gears, pulleys, inclined planes, wedges, and screws. For today's lesson, we're only gonna focus on the inclined plane and the pulley. Let's start off with the inclined plane. Inclined plane consists of a sloping surface that connects a lower and a higher elevation together. Additionally, the object's weight will be supported by the sloping surface as it moves up. Ramps, slides, and stairs are few of the inclined planes found in our daily lives. Roadways connected to a higher surface such as bridges are also plausible examples. Pulleys, on the other hand, is a grooved wheel combined with a rope that enables you to raise, lower, or move a load. When combined, you can form a block and tackle or compound pulleys. The best example of a real-life application are elevators and water wells. Moving forward, we're gonna tackle sample problems with the use of these simple machines. Good day everyone, today we're gonna tackle a problem using Newton's second law in an inclined plane with friction. This means that there's a friction between the object and the inclined plane. To start, let's say you are a geologist and your job is to monitor the Mount Pinatubo. But before the end of your shift, you have been informed by your colleagues that an erosion has occurred at the slope of the mountain. According to the data you have received, the stone is 47 kilograms, placed in a slope with an angle of 37 degrees with respect to the horizontal, and a coefficient of friction of 0.4 between the mass and the incline. Our job is to compute its acceleration before the townspeople below the mountain gets affected. Before we start with the computations, let us first collect the data we have gathered. The first given is the mass of the stone, which is 47 kilograms. The angle of the slope, represented by beta, 37 degrees. The coefficient of friction, mu, equal to 0.4, and the acceleration due to gravity, which is 9.8 meter per second squared. With that out of the way, we can now proceed to write the required outcome of the problem, which is the acceleration. To make things easier, we can draw a full body diagram to further understand the situation. We're gonna draw an inclined plane to visualize the mountain slope, followed by a circle which represents the stone. After that, we can now input the values where they belong. So the stone weighs 47 kilograms with an angle of 37 degrees on a horizontal plane. And a coefficient of friction of 0.4. And finally, find the missing value of the acceleration. To solve a problem like this, we're gonna use Newton's second law, which is force is equals to mass times acceleration, or F is equal to m times a, which we will derive then to a is equals to F over m. Since we are dealing with acceleration, we're gonna use net force because it's the force that causes the acceleration. Now we're gonna find the net force by drawing the force vectors, leading with the force due to gravity, which is mass times gravity, or mg, followed by the perpendicular and horizontal components of that force. Here's the mg cosine theta and the mg sine theta. Once we have the components of the weight can be replaced by those instead. The angle here is also the same as the given angle. Because the mass is pushing down the plane, it means that the plane is also pushing back against the mass. Newton's third law explains that there is equality in opposite forces, so this means that the normal force, or N, is equals to mg cosine theta. As you can see, the forces cancel each other out. Knowing that there is friction or friction force, it is always directed on the opposite of where the object, in our case the stone, will slide down. Friction force keeps the object from sliding down the inclined plane. So the formula for friction force is equal to normal force times mu. And since we already have the formula for normal force, we can substitute it to mg cosine theta times mu. To explain it briefly, if mg sine theta is bigger than the friction force, then the object will slide down. But if the friction force is bigger than mg sine theta, then the object will stay in its place. Now that it's out of the way, we can now go back to our equation. If you're still wondering how we derive Newton's second law, here's how it goes. Divide both sides by mass and cancel out the pairs. And that's it. Because we've cleared out the map for the force vectors, we can now use them as a guide for the equation. Acceleration is equals to the net force over mass, which is then equal to mg sine theta, the force that accelerates the object, minus mg cosine theta times mu, which prevents the object from accelerating, divided by the object's mass. We can still simplify this equation by factoring out the mg. This equates to mg times sine theta minus cosine theta times mu divided by the mass. Let's cancel out the mass, and the final equation to be used for the problem is acceleration is equal to g times sine theta minus cosine theta times mu. For the solution, we're gonna substitute the values. So we're gonna write down the equation again. So G is 9.8 meter per second squared times sine 37 degree minus cosine 37 degree times the mu. So you're gonna use a calculator. 9.8 meter per second squared times sine 37, which is 0.0 6018 minus cosine 37, which is 0.7986 times the mu, 0.4. Okay, gonna input it in the calculator again. 9.8 meter per second squared times 0.2824. Okay. With that being said, our acceleration is equal to 2.7675 meter per second squared. That's for decimal places, so we're gonna round it off to 2 decimal places. So our final answer is acceleration is equal to 2.77 meter per second squared. And there we go. If you wanna do it, you can also convert your final answer to this. Therefore, the acceleration of the 47 kg stone in the 37-degree slope of Mount Pinatubo with a coefficient friction of 0.4 is 2.77 meter per second squared.
So welcome. We are going to solve and talk about pulleys. So let us define what is a pulley. Pulleys are mechanisms composed by a wheel and a rope used to lift heavy objects onto tall heights. So we have a problem here, let's try to solve it. A 29.7 kilogram concrete block rests on an inclined plane and is connected by a rope with 10.16 kilograms bucket of water. This second mass is suspended over a pulley. The inclined angle is 38 degrees. The coefficient of kinetic friction is 0.33. What is the acceleration of the system? Calculate the tension of the rope. So the problem is we're going to find the acceleration of the system and the tension of the rope. So what is our M1 or first mass? So it is 29.7 kilograms. 29.7 kilograms. And our M2 is 10.16 kilograms. And our angle is 38 degrees. Our gravity is supposed to be a lowercase g, so 9.8 meters per second squared. And our kinetic friction will be 0.33. Let us check if it is right. So 29.7 kilograms first mass, the second mass is 10.16 kilograms, right? And 38 degrees for the angle. Also kinetic friction is 0.33. So let us proceed. So the problem states we're going to find acceleration and the tension. So we have a given, the formula is now given. So see here how they derive the formula. Summation of forces is equivalent to mass times acceleration. So they divide both sides by the mass to find the acceleration. And the summation of forces is equivalent to the m1 multiplied by the gravity multiplied by the sin theta subtracted to m2g minus the frictional force, and the acceleration or is equivalent to the tension minus m2g divided by m2, or the formula for the tension is T is equivalent to acceleration multiplied by m2, or the second mass, plus m2g. So the solution will be, so let us first find the acceleration. So our m1 is 29.7 multiplied by 9.8 multiplied by sine theta, sine angle 38, subtracted by m2, which is 10.16, multiplied by the gravity, which is 9.8, minus the frictional force, 0.33, and multiplied by the m1, which is 29.7, multiplied by the gravity again, and lastly the cos theta. So cos multiplied by cos 30 all over by the mass, which is 29.7 plus the 10.16. So if we compute here, let's grab our calculator. So sin 30 minus 10.69.48. So we have here our acceleration will be 0.10 meters per second squared. Now, for our tension is equivalent to the acceleration 0.10 multiplied by m2, which is 10.16, plus the m2, which is 10.16 again, multiplied by the gravity, which is 9.8. So our answer would be, let's calculate it, 0.10 multiplied by 10.16 plus 10.16 multiplied by 9.8 is equivalent to 100.584. So let's convert it to 2 decimal places. Let's round off numbers by 2 decimal places. So it will be 100.58, and our SI unit would be Newton. So this is how you solve for the tension and the acceleration of pulleys. So thank you and have a wonderful day.